Wireshark is a tool that lets you inspect network traffic on your computer. So if you want to see what's actually happening under the covers between your web browser and the internet, or between your computer and other devices on your local network, Wireshark is going to let you peel back the covers and see what's going on. Now, network traffic, there can be a lot of network traffic, and Wireshark gives you a detailed view, so it can be a fairly intimidating application to get started with. So we're going to jump into it. We're going to go to the Wireshark download page. I mean, you can just Google it or just go download it. I've got the link right there to the download page. I'm running this in Windows. Wireshark is available for Linux, Mac. It's available everywhere. I'm going to just use the latest Windows x64 installer. I'm running this inside my virtual machine on the Amazon cloud. You can run it on your desktop. It doesn't really matter where you run it. It'll work everywhere. I'm going to kick off that download. Download should happen pretty quick. It's cruising. Of course, the Amazon cloud has a very good internet connection, so it's going to go pretty quick. Once it's downloaded, I'm going to go ahead and install it. Going through this installation, we're going to accept basically all the defaults. Next, next. Yep, sounds good. Everything's good. Just click next. Sure, stick it in the start menu. That's fine. Associate it. Put it with files. Put it in the start menu. Sure, that's fine. We are going to install the npcap. That's the tool that's actually going to capture the packets. That'll kick off a separate installer as we go through. It'll happen automatically, but we're good. We do not need the USB packet capture unless you're going to go to the Amazon data center and stick a USB drive into their server. So leave that unchecked and install. So it'll take a little bit for these files to be installed, and that's totally fine. Basically what we're going to do is we're going to run Wireshark. We're going to capture packets as we browse the web, and then we're going to take a look at what is actually in those packets inside Wireshark. So here's where the npcap installation got launched. So yep, that's okay. I'm not going to change any of those options. I'm going to click install. So we're really installing two tools, Wireshark and the network packet capture software, which is just fine. Now, the first time you run Wireshark, it's going to seem like a fire hose of information. The second time you run Wireshark, it's still going to seem like a fire hose of information. The 20th time you run Wireshark, it's going to start to make sense. Your eyeballs just have to learn what information is relevant and which stuff you just don't currently care about. So I'm just going to keep proceeding with the installation, keep clicking next and next until we are good to go. Completed. Next. I don't care about the news, so I'm just going to go ahead and click finish. And Wireshark, the installation should be good. Okay, so running Wireshark. We're going to have a web browser open as we go through it. I'm going to have a couple of windows going. So I've got the instructions on the left. I'll just have a browser tab just kind of floating around here in the middle. And then I'm going to launch Wireshark. So I'll bring Wireshark off to the right. Now, when you launch Wireshark, you have to tell Wireshark, like, well, what network interface do you want to use to capture packets? Because on your computer, you might have Wi-Fi. You might have a wired Ethernet connection. You might have Bluetooth. You might have a bunch of different network connections available. Here in the Amazon cloud, it's Ethernet 2. If you were running Wireshark on your laptop and you wanted to capture packets on your laptop, you would probably look for the Wi-Fi connection. I'm just going to use this Ethernet 2. You can see a spark line here of traffic If you've got a bunch of adapters on your computer, you'll see a bunch of different spark lines there. Typically, the most active one is the one you want to capture the traffic on. So I'm just going to double click Ethernet 2, and I'm going to automatically start capturing packets. And I'm going to see all these packets here. All these packets, they're actually the data sent between the remote desktop and my host computer. So all the frames, anytime I move my mouse and I do anything, that data is being sent back and forth. So that's most of the traffic I'm seeing here in Wireshark. Every little change in pixels that's being sent over the network. I'm going to come to my middle web browser. So that's the spare one I had open, and I'm going to go to cnn.com. And I can see over in Wireshark, I've captured thousands of packets, 15, 16, holy cow, that's a whole lot of packets. All right, I'm going to click the red square button there to stop this capture. No more packets are going to be captured right now. We stopped the fire hose. But I've got a ton of information. I can see the source and destination. So this source 172.31.50.50, that's the IP address of my computer here, 172.31.50.50. And the destination, that's where it's sending that data to. All right, so we stopped the capture. We've got all those packets. So what the heck are we going to do? Depends on a lot of factors how many packets you're actually going to have here. I've got close to 24,000 packets. When I did this previously and I captured a screenshot of the same process, I had about 6,000 packets. A lot of data to sift through. So if you wanted to go one by one, it's going to take you a long time to figure out what's happening with this traffic. Most of these, it's going from this virtual server, this 131.150.136.111. That's my host computer's IP address in Marquette, Michigan. So packets are going between this server and my home desktop just to stream all the packets for the remote desktop protocol. So those aren't that interesting to look at. It's just little frames, little changes in the screen, just so I can see what's happening in real time. We can filter this out. So I can add a display filter. So apply a display filter. If I just come up here and I type D, D is not a valid filter by itself, so the background here goes pink. If I type DNS total, that is a valid filter, so it goes green. If I just hit enter, it'll apply that filter. And I can see all of the DNS queries that happened when I went to CNN.com. And holy moly, there's a whole bunch of them. So I can see the packet numbers. They will go up in order, but it won't be sequential. So it took me a few seconds before I started this capture, before I actually went. It took a few seconds for me after I started the capture to actually load CNN.com. So it took me about 27.6 seconds before I typed CNN.com in there. There's CNN.com. There's the DNS lookup. My computer automatically behind the scenes created this DNS query to go figure out the IP address for CNN.com. I'm going to expand Wireshark because there's so much information. I want to show as much as possible. Up here, all these are, every row is an individual network packet. So if I click on one of these, I can see the details in this bottom left corner over here. So I selected a DNS record because I filtered, I'm only showing DNS records. And I can see information about that query. I'm going to scroll down, make sure I'm going through my instructions, not getting too far off base. So we see the source and destination. I looked this up. This 172.31.0.2, that's Amazon's DNS server in my environment. Yours if you're running this in Amazon, should look similar. That's who I queried. And I eventually got a response. If I look down here in this response, I can see where the answer came back. So I said, hey, where's the IP address for CNN.com? I got a response from the server, and that's in this particular packet. Packet 1639. 1639 is right here. I can take a look at that. I can either use that link, or I could just highlight that packet. So I can see the response came from the Amazon DNS server to my server. Said, well, we can look at the answer. Yeah, you can find CNN.com. Right now it's at 146.75.35.5. So my web browser and operating system took care of this automatically. But if I wanted to peek behind the covers and see what's happening, I can totally do that. Notice this is coming, it's unencrypted, so I can read this. So DNS, the protocol, by default, does not encrypt your DNS lookups. So even though the contents of the page, when I go to CNN.com, it's using HTTPS so that the content of the page is encrypted, but DNS does not encrypt my lookups. So if I'm on a network and I go to poker.com, well, anyone who can sniff that packet, anyone who can see my traffic, like the IT administrators, they can see in clear text, yep, Jim went to poker.com. So it's no secret what websites I'm visiting. So it's not great for privacy. There are different ways to actually encrypt this data, but out of scope for our discussion right now. Tons of information. We can see the source computer, the destination computer, what protocol is being used, how much data was in there, and the info is kind of a friendly, I'll put friendly in air quotes, summary of what this actually was. So everything's working fine. We're looking at the packet details. All of that is good. So who cares? Well, if you are a network administrator and something weird is happening on your network, or you're looking for signs of attack, or if something is just not working properly, you can launch Wireshark and you can see the network traffic in real time and try to figure out like, oh, this computer can't connect to this server because we can see what protocol specifically is failing. I've used Wireshark before when my computer would not get an IP address. So I launched Wireshark and I tried to see, is my computer even asking for an IP address or what's happening in the process? A lot of the analysis of these network packets, so I captured packets for just a few seconds, a minute, and I got thousands and thousands of packets. It's too much for a human being to manually sift through. You don't want your network administrators looking at billions of packets every day trying to manually detect what's going on. A lot of tools that run on the servers to protect your network will try to automate the analysis of these packets. They'll apply machine learning techniques. They'll look for malicious traffic or known malicious IP addresses, those types of things, and they'll try to flag malicious traffic automatically. One thing that the threat hunters do is they'll come in after the automated scans and they'll take a peek and just kind of say, okay, the automated scans didn't find anything funny, but is there something that just kind of sticks out to us? So how would something stick out to you? If you're brand new to computer networking and this just looks like a fire hose of information, it's like, what the heck is going on? Yeah, it's going to be really hard for any of this to trigger a question in your mind, like what doesn't look right here? But the more experience you have with computer networks, building networks, troubleshooting networks, the more likely you'll be able to see something that's just not quite right. One thing we might think about our network now is did everything work okay? Like CNN.com loaded fine. Why the heck do I have Bing.com? Why do I have WarnerMediaCDN.com? Why do I have all of these DNS requests for websites or domains that I wasn't going to? Well, if you look at the CNN.com webpage, they might be loading images. They might be loading advertisements. This one web page might point to content in other domains. And so your web browser does DNS lookups for all of that content. This is one way that your activity is tracked on the internet by you loading content from all of these different sources. So this is how the web analytics companies start to piece together who you are, what sites you typically visit, what are your demographics, what might you be interested in buying, all of that kind of stuff. I don't currently have an ad blocker running in my web browser. If I had an ad blocker running, the ad blocker would have blocked a lot of these domains from being loaded. So it can be kind of shocking to realize just how much content is loaded just by visiting one web page. That content's loaded from dozens and dozens of different domains to make the web page work the way CNN designed it to. So there's a lot that you can peek through in Packet Tracer. I'm going to clear the filter. Currently I've got this DNS filter. If I hit this X over on the right hand side, the top right, it'll clear that filter. It's going to show me all of the packets. I can type a different filter. I'll type TCP. And if I look through these packets enough, I will eventually find a TCP handshake. A handshake, like here's part of one. It might not always be in order because we might be establishing multiple handshakes at the same time. But the server is trying to establish a handshake, let's take a look at packet, in my case, 15,857. Oh, that's an acknowledgement. It starts with an SYN packet. Where did that start? If I find, I'm trying to find something that's easier to interpret, something that's formatted a little nicer. Why don't I jump to the top and just see? My computer had established a connection with my desktop to send all the remote desktop protocol stuff. So around 30 seconds, I'm going to go down in the timeline. That's when I went to CNN.com. So I'm going to make you dizzy. I'm going to page down through all this stuff. A lot of data. That's when I actually tried to go to CNN.com. The TCP protocol breaks data into chunks and sends that data and tries to verify that we actually got the data. And it sticks it all in the right order. So I'm seeing some pieces of the handshake here. Oh, that's fine. I'm looking for just a SYN packet. I'm going to pause the video, find a better example. All right, just because of the way the networking is set up on Amazon. So we have the synchronization packet with a couple of extra options. We can kind of ignore those. Then we have the synchronization acknowledgement and then an acknowledgement. So that's the handshake. So after we do that handshake, we can start sending data. So it looks a little bit messier than the example screenshot here. But that's the way the protocol works. All that's fine. If I right click on one of these packets and I choose follow TCP stream, it'll try to reconstruct all of that data. And I can use the stream number in the bottom right to switch between streams. And we don't see much that's actually useful. Most of this data is just encrypted, so we can't read it. So this is the contents of the web page that we're sending back and forth. It's all encrypted data. So as an IT administrator, this doesn't really help me. So I'm going to close this follow stream window. And I'm going to clear the filter. I'm going to do another capture this time. I'm going to capture a website that will send some data that is not encrypted. So I am going to go to http://neverssl.com. I'm not going to hit enter though. I'm just going to have that ready to go. I'm going to come back to Wireshark and I'm going to say capture. I'm going to click start. It's going to ask me if I want to continue without saving. Sure, continue without saving. As soon as I click continue without saving, it's going to start capturing packets. So I'm going to switch back to my web browser and I'm going to hit enter and it's going to load that web page. I'll come back to Wireshark and stop. So I just want to capture just a tiny little bit of data. Okay. I'm going to look here in this protocol. You can sort. I'll click on the protocol and sort it. Here I've got this HTTP protocol. So I'm going to right click on that and I'm going to say follow HTTP stream. And what do I see here? I see something that looks like text. This is not encrypted data. This is the contents of the NeverSSL web page. If you can read HTML, you can read all these tags, you can kind of make sense of it. Or we can finally get down here. We've got some paragraphs of text that describe what this web page is doing. So if I compare this stream to the actual web page, they'll kind of match up content-wise. Like this website is for when you try to open Facebook, Google, Amazon, etc. on a Wi-Fi network. This website is for when you try to open Facebook, Google, Amazon, etc. on a Wi-Fi network. So this is part of the reason why HTTPS is important. If I was viewing this neverssl.com website on a network, people would be able to see the traffic going between my machine and the internet. If I entered a password on this website, it would be sent in clear text, so it's not encrypted. So when I followed the stream, what Wireshark did is it found all the packets used to send me the contents of that web page and kind of smushed them all together in one view that was easier to read than looking at all the packets manually. So take a look at Wireshark. Play around. You can clear your filters if you would want to see all the packets. Try right-clicking on an HTTP packet. Follow that TCP stream, or follow that HTTP stream would be better in this case. It'll show you the web page. You can try that with different protocols, see what it gives you. Just the more time you spend playing around with Wireshark, the more familiar things start to become. And of course, the more you learn about network protocols, the more this information is going to make sense. So as far as capturing data in Wireshark and just looking at the packets, I think that's good for right now. We'll get into analyzing network packet captures a little bit more in detail to look at different kinds of traffic.